In this video, you will learn how to write and solve a linear inequality when given a context. When we solve word problems, it's good to look for keywords that help us figure out what we should do to solve the problem. If you look at the top of this table, we have the 4 different inequality symbols. And below it, there are some different keywords that may show up in the context or in the word problem. These keywords will help us know which inequality symbol we might want to use when we solve the problem. It might be a good idea for you to take a screenshot of this and put it into your notes and into your learning plan. Our first word problem tells us that the yellow cab taxi charges a $4 starting fee in addition to 50 cents per mile. Kathy can spend no more than $20 on a ride. So if we look at the word problem, we can see that we already have some keywords. No more than. That means she has $20 and she can spend up to $20, but nothing more than $20. So you might think that the cost of her trip has to be less than or equal to the price that she has to pay. Now we can put some numbers with this. The cost that she's going to be paying first starts with the $4 for the starting fee, and then it's going to be adding 50 cents for every mile. And that amount has to be less than or equal to $20. So she can spend $5, or she can spend $10, or she could spend all $20. So that inequality right here represents Kathy's situation. Now the second question says, how many miles can Kathy travel with the amount of money she has? In order to figure this out, what we can do is we can solve the inequality. This is what we were doing in Learning Plan 3.1. Remember, we're going to solve this just like an equation. So I'm going to start out with first subtracting 4 from both sides of the inequality. That's going to leave me with 50 cents times m less than or equal to 16. Then my last step is to divide by the 50 cents. That's going to give me m is less than or equal to 32. So what this tells me is that she can go less than or equal to 32 miles. She could go 10 miles, she could go 20 miles, or she could go all 32 miles, and she would have enough money to travel that far. I would want to write my answer just like this, because this is showing all of the solutions. 32 miles is the most, but she could definitely go less than 32 miles. The next problem says that suppose you intend to spend $60 at most buying books. Hardback books cost $12 and paperbacks cost $5. So we have a couple more keywords in here. At most. That tells us that 60 is the highest number, that whatever you spend, it has to be less than $60. The thing that's different with this problem is that there's two things. We have two variables. The hardback books cost $12 and the paperbacks cost $5. So we're going to have two variables in our inequality. To represent this, I could say that the hardback books cost $12, so 12H, and I'd add that to the paperbacks, which would be $5 P. I'll use P to represent paperbacks. Now what I spend on those books, it cannot be more than $60, but it could be equal to it. So I'm going to use the less than or equal than symbol in my inequality. And it's going to be less than or equal to 60. That means the amount that I spend on my books could be $12, it could be $35, or since it's less than or equal to, it could also be $60. Now the next question says, list 3 combinations of hardbacks and paperbacks that would satisfy the inequality. So there's a whole bunch of different combinations that we could come up with. Here's a few that I could write down. I could buy 2 hardbacks, and I could buy, let's say, 4 paperbacks. That would mean that on hardbacks I spent $24, and on paperbacks I spent $20. So I spent $44. That is less than $60, so that works. I could also buy 1 hardback and, let's say, 5 paperbacks. That means I'd spend $12 on the hardbacks, and 5 times the $5 would be $25. So that would give me a total of $37. $37 is less than $60. And one more combination. Let's say I got 3 hardbacks and 2 paperbacks. So 3 hardbacks would be $36, and the paperbacks would cost $10. So I'd be spending $46. All of these combinations would be less than $60. So all of these combinations would work in this in this inequality. When you get to Learning Plan 3.3, you're going to see how graphing an inequality like this will let you show all of the solutions. If you have any questions, please talk with your teacher. Otherwise, continue on with your learning plan.